So I start off making this part by creating a new milling list. In this part, I make the stock material to be slightly larger around the X and Y and Z axis, and this is just to allow access for cutting. Then to choose a face to put the milling on, I need to just click on the actual item itself and then proceed by clicking OK for all the other options. The first thing I do is I create the tool list. In the tool list, I'm going to first create the first tool for the milling procedure, and this will be the tool used to take off a majority of the material around the actual item itself. As you can see there, they are the dimensions that I've chosen for this milling operation. The second tool that I've used is going to be a 10mm bit, and this bit will be used to drill the holes around the actual unit itself. So I just save that like the previous tool and move on to the third tool. So the third tool is going to be a 6mm diameter drill bit, and this milling tool will be used for the smaller holes. So to start off, I add a milling operation, and in this case it's going to be a 3D milling operation. I then select the working area and define it as being the outside of the actual unit all the way to the central stock. And this means that I'm able to mill and remove all the material in between those two parts. I then select my largest tool, which is the 25mm diameter tool bit, and then press accept. Go to the next part, which is the levels. The upper level that I want to use is going to be left as 0, but the lower level I'm going to set to the part that was just highlighted so that I can remove all of that section first. For technology, I put it to contour and I leave the rest as is. When I simulate it, that's the result I get, and that's the toolpath that the milling tool will follow. As a 3D simulation, this is how the procedure will look, and these are the paths that will be undertaken by the actual CNC milling. So I make a second milling operation. In this case, it's going to be a 3D milling operation again. I click on the working area and go to define the working area. So same as the last one, it's going to be to remove a majority of the material, but it's between those 2 points this time. So it's the lower section of the actual item itself. Once that has been defined, then I go to the tool section, and in the tool section, I will choose the same tool that was used in the previous part, which will be the 25mm diameter tool, in order to remove the material quite quickly. The upper level I'm going to set though will be the part that was just highlighted, and that will go down to the actual base part in order to speed up the time. For the technology, I'm going to change it to contour, and then I will proceed by accepting that. I then calculate this to see what the path will look like, and as it's the right path, I'm happy with that result. I then go to do a 3D simulation, and as you can see, it worked quite nicely. So I add another milling operation after this, and this milling operation is going to be another 3D milling. Again, I'll choose the working area, and the working area this time that I want to select is the central part, which is going to be that hollow section in the middle. The tool I'm going to use is the same tool again, because it's it's the largest tool that we have, and it will remove the material the fastest. The levels, it's going to be right through, so that's fine. And for the technology, I'm going to change it to contour, similar to the others. So after simulating, that's the result I get. Same with the 3D simulation, which is the correct one. After this, I do another setup, and I do a drilling operation. For this drilling operation, I'm going to drill the 5 holes, as you can see there, around the center. So I do this by turning the item over in this CAD model and clicking on where I want the tool bit to go to. For the tool bit though, I'm going to choose my second tool bit, which is the 10mm diameter tool bit. For the levels though, I'm going to leave them as they are because it's going to be drilled right through, And for technology, I'm just going to leave that as is. After this milling operation, I'm going to do another one for drilling. For this drilling operation though, it's going to be all the holes around the outside of the actual item itself. So to do this, I had to turn the 3D model over and click on the back side of the holes. For the tools, I choose the third option, which is the 6mm diameter tool bit, the smallest tool bit. So this should be able to drill straight through the hole. The upper level I'm going to choose as being the top part of the base, if you look from the top view, and the depth I'll leave as is. Same as the technology section, I'm going to leave that as is. So if I calculate all the sections together, it shows me the outcome of the tool path, and upon analysis this is the correct tool path and operations that will be required to remove the material to form this particular item. So if I simulate this in a 3D simulation and speed it up a little bit, you can see that the tool is going to be following this particular path, and as such it's going to be able to perform all the operations in order to have the desired outcome. So for the last one, I'm going to add a profile cut. So this profile operation is the one that's going to go right around the outside of it, and this is going to make the outside nice and flush and smooth. And for this, I'm going to use the first tool, as it is the largest tool and it will require the easiest amount of effort. For the levels though, I'm going to leave them the same, and the technology as well I'll leave the same. I've put it on left side for this operation so that the tool bit is on the correct side of the actual item itself. So if I calculate this, you can see that the tool bit is on the correct side. And in order to generate the G code for the machining operator, you just follow that function there, and it produces all the G code necessary to perform the actions by the CNC milling machine in order to obtain the required design in the part. And this is the general layout of the toolpath that will be required for this operation. So after that's done though, there's some milling that needs to be done on the underside. So in order to do this, you need to take the actual item off the milling machine and turn it the other way around so that the underside is now facing the top. After that's done, you can start this operation. So to do this operation, I've created a new tool in the parts table. This tool is going to be a 15mm diameter tool bit, and I'm going to save that and then start with my first operation. So for my first operation, my first milling operation, I'm going to start with a drilling operation. This drilling operation is going to be on the new top face of the part, and it's going to drill down to the part that I'm now clicking on. So once all 5 have been selected, I can choose the tool bit, and as this is a new milling operation for this example, I just choose number 1, and I leave the upper level to be 0, and the lower level I make it to the depth of the cut, which in this case is 3 mils. The technology I leave as the same, and I save that and exit. By calculating this cutting, you can see that it's the correct approach, and you can see that the tool bit is following the cut quite nicely. So this is an example of what the tool bit will do as far as the toolpath goes for these cuts.